Hello, everybody. This is Daniel speaking. Thank you for joining us today. Today, we are continuing with our webinar series about how to import any tool components in ToolKit. The interesting was so big. We have received so many questions, and I'm again very thankful for this. I will try to answer and as much on these and the most frequent that we have from the previous webinar. And this is how I'm going to start this webinar. And continuing to that, I will basically talk more about, again, the milling tool components, where we'll mostly spend our time on specific joint characteristics and the way how to define angular holders, and also a couple of nice features to be added also in this webinar. So the very first question was like, where we can download, the all the recordings and presentation stuff. All of you have asked this. I will just try to go over that. Let me just. So all our recordings basically will be stored in the reseller area over here, or you can also find it in the webinar section, and you can go to the webinar recordings. Here you have the section of latest webinars. And basically here you will be able to download the video or download the part, watch the the video, also download the presentation or stuff. Truly speaking, last time it took us like 2 days to upload the part and presentation. So if you don't see it here, just after it is uploaded, soon it will be there for sure. So every next webinar, basically it will be here as well. Okay, so let's go back to our project. In this particular case, in this particular webinar, I will not have any kind of presentation. I'll just immediately go into the software and show you a couple of nice components that I prepared for now. The part is the same, the kinematic is the same, everything is the same. We'll use the same library, everything will just continue. So the next question that came last time was, okay, we do have like a library from previous previous versions of SolidCAM, and how we can actually import it into a new one. Okay, so this came like many times. I think I need to speak about this a lot, because many of you didn't notice it, and I will gonna show you how actually you can do it. So in this case, I will edit a tool components or tool assembly library, doesn't really matter. I'll just go to the tool components itself, and I'll just open this webinar TLV that we had last time. Now, if you do something like this, on the very left at the bottom, you have an icon that says, import from machine tool setup library or any CAM tool table. If you click on the right button over here, not really on the icon, but on the right arrow here, you'll be able to import any component, either that is a tab file, if you're familiar with the previous version, that will be a tab file, or you can directly import it from the CAM files. So I'll leave it as a CAM file for the PRZ. I can jump to any location where I have existing CAM part. For example, this one, which is imported directly from SolidCAM 2019. Let me go there. It is machine. I can take any of these. I'll just pick it up. So what will happen is that it will pop up a lot of tools. All the holders will be there. So you can basically just use the drag and drop to your library just like this, and that's the way how you can actually do it. It's pretty easy and pretty simple, right? So that's the first way, and also you can as I should show you earlier, you can also take the tab file in the same manner. Okay, so this is the way how to do it. Now there is also a nice feature that I want to show you on top of that question, was that if you open already existing CAM part, for instance, maybe it's the CAM part from another a machine or something, but you're interested just to take that particular one. You don't want actually to go into the to repeat the steps that I just showed you, but you just want to directly put that particular holder or the tool, we can also open the tool picture here. And what it allows you to do is to save everything as the STL. Now you can do a right click here, and here you have save as STL. So you can basically do it and just store it wherever you want in this folder, and then later on organize it according to your needs. I didn't tell you previously, but doing importing from this way, it will basically, let me just repeat it again. I want to show you one small detail there. So let me go to the here, let me go to the machine, and let me open this one. So if I try to import it like, I don't know, like this, for instance, I'll close it definitely. What you will see here is the path where it will be. So holders STL / and then the STL name, it will be a default position of your STL where it is stored. So you can basically make a manipulation based actually on this. All right, so that's the oh yeah, I have also another one when so you can also, by the way, take the selfie. That's also something nice. You can use it for a tool sheet or something. You can take the print screen of your tool viewer at any time. It will be stored like this. You can save it, you can manipulate, you can use it for documentation or any. I think it's a nice feature. All right, the next thing is, yeah, it was a nice question coming from about the tool components library, where we use the Shanks here. Where it is, yeah. So we use the round or square shank, and somebody asked, is it really not, important which one I use for tool components like Collets or something? It's currently it's not important at all. It's in the case you're using parametric data, then of course, if you really want to use round shank, then it matters. But if you really want to just use it to put the 3D model into it, it really doesn't matter which one actually you would use. Okay, so this is, we are thinking to put another element here, which will be like 3D component or something, that will not be connected directly to the shank itself, but we'll see about that. Okay, another question which came in, and this is the last question that I prepared before I start the webinar, really, is the question that was connected to the parameter in the VMID that is shown to display the rotation of the holder and stuff. And here, I will pick up one of the tool here. Let me check which one I took there. I say that this parameter, it may require the change on your holders, maybe even the post, it depends, but in most of the cases, like in this one, I will take the cutting point, and what happened here is that this holder itself was taken like directly. It's imported from a previous version, of course. And in that case, you will probably see something like this, which is completely wrong because the cutting point, the tool offset, it's connected over here, but the compensation, obviously circle here, is displayed in a not correct plane. So the secret is that you'll need to define this holder as a gear. Okay, so this is a gear, not like going directly, and then it will only, this one will only rotate. Of course, also what you can note is that this joint of this particular holder goes in X direction. So the rule is, I will just repeat it, always it must go along the Z axis, and then everything will work fine. As you can see, if I click on the cutting point and you can see this Z axis over here, then this circle, it's pointing on that particular Z position of that joint. Okay, so let's now jump into two components. So I will be, I have prepared for the first one. Let me just, where I am here. I prepared for the first example, the fly cutter. But before I open the fly cutter, I would like to show you this nice example. The boring part, because I want to show you one very nice feature in SolidCAM Toolkit, which is called linear joint, which basically allow you to linearly move particular elements along some axis. And as you can see, this one, it's completely obvious that changing, the linear position along the X in this direction, it will definitely have an influence to the diameter. Yes, of course you need to unscrew it, screw it again, and you can use this tool as well. So I think even with the knowledge that I show you so far, defining this tool wouldn't be a problem up until the part with the linear joint itself. But I will not use this example, as this one, it's, I think, a bit simpler than in comparing to what I'm going to show you. So I will open the fly cutter here. Even though that this looks maybe not so attractive, I would dare to say that this one is even more complicated than the previous one. And you will see, the right way to define this kind of tool. What you will first note is that even this shank can have the screws over here. You can unscrew it and move it along, not directly x-axis, but it is a specific axis that we are going to define. And I'll show you actually how you can do that in SolidCAM. So let's basically jump into it. So first thing first, I will define the coordinate system position over here. So I'll just create a simple point, and I'll create a coordinate system. Again, I just repeat Z on the top, X and Y, it's not important at all. I'll just click OK, and I'll just rename this to like holder. Right, now I will hide these two components. I don't really need them. I have here some solid bodies. Perfect. Now, where will be my joint? My joint would be probably here at the bottom or here in the corner. It actually really depends on you on which is the point that you would like to be controlled. In this example, I'll just put it in the middle. So I will control the middle point, but actually you can put it anywhere. But for me, it was more like logical to put it in the middle. So what I'm going to do, I'll just create a sketch, and I will make a plane like this. Not really helpful, to be honest, but I will just create a simple line. I'll just can I maybe, yeah, why not? But I'll do the old-fashioned. I'll just make sure that they are parallel and just do it like this. And what I'm interested is maybe this line over here. I will convert it, and I will basically say this also is a construction. So what I'm interested is to have this point over here. I could also probably select the middle point here on the edge, and yeah, but I just wanted to have this more controlled, let's say like this. Yeah, I forgot one thing. Why I went to the sketch, I'll just make a point in the middle, and now I'll define the coordinate system. My point will be here, that's for sure. My z-axis will be along this line, and that's basically it. Maybe I can also make x-axis opposite, but this is really doesn't matter too much. I'll just OK, and I'll just click that this is my linear joint. Perfect. Now I will unhide the shank. And for the shank, I will just create a coordinate system here. This is super easy. I'll just create a coordinate system along the z-axis over here. I'll just flip it, and I'll leave it the coordinate system as it is here. I'll click OK, and I'll just for webinar here, I'll just change the coordinate system name. I'll just call it shank. Perfect. Remaining stuff is that to create the insert joint, and this is also pretty much routine. I'll just put the coordinate system z-axis over here. Click OK, and I'll say this is insert joint, and then the last section is actually I have a couple of screws here, but I will not define it. Is the insert itself. Now a little bit the delta in in comparing to what I've said last time. As the last time, I have actually defined the joint of insert also over here, but also it was my output for the insert. I would dare to say now that maybe if you remember my presentation where I say that if you have an Endmill here, always define your coordinate system like this in the Z. The same rule you should apply also for insert. So even though that you have an insert, please define the Z-axis over here. In the previous webinar, we defined it over here. It's not so bad for milling, but for turning, it will be devastating. Okay, so I will give you more info about that later. Okay. So for now, I will just define also the insert position over here, where I will just try to create a plane. And my second reference would be, as you can see, this is, I'll just pick on this position. I think it's the highest point on the insert. Now, the question is that you might ask, like, where I'm going to put that coordinate system. So it's not really matter too much. The most important is it's on the top. You can put it also here, 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 but myself, it's the good practice to always keep it in the middle, you know, so then you're always fine with that. Right, so I'm over here. I will just maybe select that particular point, convert it. I have the point here. I will be using and creating a new coordinate system. And that's basically it. I will just make sure that it's on the plane. And okay, I'll call this just insert. All right, perfect. So the hardest job actually was done. So let's export this. So first, I'll hide these two, and I'll just export this folder over here. So I'll just do File, Save As. Remember where to store it. I will basically go to the metric. I already here create a fly cutoff, I think. Fly cutter, yes. But let me put it into a webinar. And I'll just call it, oh, let me go to the STL, and I'll just click here, and I'll just name it as a holder. It's not really important at this moment. I'll go to the options. I'll select proper output coordinate system, and I'll click on calls. Right, I'll click OK and save it. Now, the most important thing here, I'll just click on selected bodies. So the most important information for me is what is the distance really and the orientation between the linear joint and my coordinate system of the holder, for which, as I mentioned earlier, we will use, you know, the coordinate system matrix, where I have all these informations. For now, I will just, you know, save this as a print screen. Maybe I can type it, you know, like linear joint, and I'll just move it to another screen so you don't actually, well, I'll bring it again later. Okay, that's it. Then I will take the shank itself. So I'll hide this one and I'll unhide the shank. I will also do save as. I will go back to the same folder. STL, shank options. It will be shank itself. Because it's also, of course, it's also okay. I'll just save and exit. And I will unhide the insert. Now, again, I need to save the distance between the shank and the rotation towards the joint, and I'll use the same coordinate system over here. And I'll just say insert joint just to be more organized. I'll also move it to another screen. Now, you'll probably know why I didn't hide this. Actually, let's imagine that I actually forgot to hide this shank and I export the insert, okay? So just give me a few moments. I want to show you something. I'll go to metric. I will go to the webinar, fly cutter, STL, and I'll call it insert. Options, this time I'll go to the find resolution, insert, and I'll click OK. Done. All right, super. Let me go back to my SolidCAM. I will edit my tool components library first. Either though you can actually, we can also import it directly into a part tool library, but in this example, I will just use, define everything in the components level and then into a CAM part itself. So let's create a holder. Holder is a holder. I'll just go 3D model. I will just go to my fly cutter, and here I'll define a holder. Okay. Now we have here the information where it is mounted, as I will not change any position over here. This one, it's fine, except that I'll just took this linear joint and I'll just put the values of the shift and rotation. The shift is just like minus 80.1 in this case it was, and RX, RY was minus 70, and that's basically it. Now, as you can see here, I'm not changing anything. I will also not change it to linear because I want to show you the disadvantages of this. So I'll just leave it as it is. Okay, then I will take the shank. I will go to the shank and I'll define the shank. I will go to the properties. I will say it's a 3D model. Let's go to the webinar folder. Okay, shank. Here it is. I will put all the values to 0 as it took the previous information. And I just need to shift it from this point to this point over here. For this, I will use, this screenshot that I took. So I'll just move it to another screen. And this is like 6. This is 4.8, minus 73.5. And then we have like 90, 090. Looks perfect. I can also rename it like insert, position, or joint. It's really up to you. And the last thing is that we have now you can define any of these. By my opinion, I would not say it's so relevant at this moment, but as I know that it will be used as a fly cutter, I will define it as a face mill, but you can do as ever you want. And I will just define the 3D model, and I'll just go to the webinar folder, fly cutter, and then the insert itself. Nice. Okay, so now this part of why I actually exported together with the shank. I didn't have to, okay, so I made a mistake. So what is so nice is this link over here that you can see. It allows you to always dynamically change it. So now, because I know that I made a mistake, I can always, go back to my fly cutter. I can, hide this element, and now I have the insert only. I can do a save as. I can go back there again. Let me go to. I always lost myself a bit here. So fly cutter, then STL, and again I'll just overwrite the values that I have here. So I'll just call it insert. It's fine, and I'll just click OK. Save, yes. Let me go back here again, and voila. So I didn't leave the application, but you can immediately see, the results of this change. Okay, so I think you understand the point of having everything into a folder and having the library there. In this case, I will not change the diameter, as changing the shank position, it will also change the diameter itself. So I will leave that for later. And what it rests, I'll just save and exit here, and I will go to my CAM project. I'll just define it in my part table library. And remember, I'm using here advanced view. And in the advanced view, I can actually start building my tool item from top to the bottom. And if you're not using, the advanced view, then you always need to start from the cutter itself and going towards the holder. So I'm always using advanced view, not only because what I just mentioned, but I really like to see, every single station, view and those kind of stuff. It's really, everything looks more organized to me, mostly for the mill turn and Swiss type machines. I always prefer to have this view for those kinematics. Right, so I will be using this on the upper turret, but doesn't matter. I can just put it anywhere in tool magazine. So I'll just take the holder. He creates automatically the new tool item. Then I will take the shank and take the face mill. Great. Now we have a problem. So let me go to the tool preview. Oh, it looks like it works perfect, almost. Except that I need to change the face mill position here to something more like, this is a nice way how I can, put it there. You can just put it on 0 to see, okay, I'm not there. Let me go a little bit here. I'm still missing something, no problem. Measurement, click here, click there. Here you have an info, it's 0.2 more. So it's 4.8, and here you go, perfectly. All right, so here we have the circle here. That's pretty great. So this is the diameter that we say. It's not actually precise, as we never know where it will be the shank really. But anyway, in any moment you can go here, and you can change it, okay? By doing, right click, break the link. You can always change this. You can see dynamically, he always, change this position. That's very nice, okay. But now the problematic part that I mentioned. So if I'm defining, the joints like I used to do so far, how I can actually move it along this specific vector if I don't have the linear joint. So if I go to the holder and maybe change the shank position here, not the mounting, sorry, but this one, yeah. So I can do it parallel to this one actually, with the shank position like this, to move it along the z-axis of the shank itself. But what if I want to do that, in the cutting point here? So let me show you how to define this. So even though that you don't have, imagine that you don't have this, you define maybe different vector or something, you can actually create your own linear axis that you can later on control it. So let me go to the tool components level. Here's my holder, and here is the trick. Now, the reason why I create actually first direct and then later a new joint is because I want to show you also one small feature. Doing the right click, and here you have add a joint with rotary axis, and you also have add a joint with linear axis. In this case, I will be defining with linear axis. And what is so good about it, that it will copy all the data from the previous joint. So it shortens you the amount of time that you need to do this. Yeah. Now, I don't need this one anymore. But let's imagine that, I will be just deleting this. A small trick here, let me just add one static joint. And let's imagine that this static joint, it's some 0 here, or this one, it's different values or so. You can now copy the data, and then you can paste particular data. So you can paste the position, rotation, or the axis, okay? So it's a really nice option to show. Anyway, back to our linear joint. So I'll just say linear joint, and it's linear, and in comparing to the static one, it has this axis data here. Now let me go to the axis data, and here you can type the name of that specific joint. Now this is important one, because whatever you see here, as a name. It will be also later on displayed in the cutting position. So you can name it as you want. I'll just call it. Okay, I wonder what happened now. Ah, I see. Axis data. So linear, I don't know, I will call it linear axis, just it is. Axis type is linear. Also, anytime you can change it here to the rotary. I will talk about that later. Axis vector. Okay, what is the axis vector here? So I cannot click now here, but for now, I will leave it as it is. My position will be 0. My limits will be, for example, plus minus 30. I think that one, it's okay. Rapid feed, this is not important at this moment. Here we have the position, so you can trigger it, what will be a default position. For now, I'll just leave it as 0. Okay. Now, how we are defining this vector? Here we have the linear joint, but the vector that we want to output, and we say that it's along the x-axis, which means that I would like to move it like this. Okay, which is basically pretty wrong. As you can see here, axis data, we say it goes along the x. Sorry, my bad. So it's not there, but it's, let me go red. It will go in this direction. So this is not actually what we want. We actually want to go along this direction. So how to do that? So how to calculate this? Well, there's many ways how you can calculate it, how you can get it, but I'll just show you my very old-fashioned way to do it within the SolidWorks. I'll just take one. This is the z-axis, and this will be my x-axis coordinate system. Let's imagine like this. Both of them should be, completely equal, and just the length of this should be exactly 1, which represents the vector itself. And I will create, another line which represents this. Now, what this line is also the length of 1 exactly. And what we are missing the angle. What is the angle really? So let me see what is the real angle. So I'll click on this. I will click on that probably. I can see it's exactly 20 degrees. All right. So let me go back to the sketch. Let me edit a sketch, put dimensions. I will just say it's 20 degrees. I'll also put this as 1 just to be sure. And now you can actually take the X component, there it is, and you can also take the Z component. Here you go. You, of course, in SolidWorks, because you don't know what is the X, what is the Z, will take the sign accordingly. I'll just take this again as a screenshot, I'll move it to another screen. And let me go back there. Fly cutter, no, we are in the pod itself. And then I'm sure this was open to me. Okay, anyway. Edit, sorry, I'm too fast in this case. So edit tool components. I will go to my webinar. I'll click on the holder. It's linear, okay, axis data, right. Okay. Again, sorry. So we need just to write the values here. So how you can do it, we have on the z-axis, we have 0.34, 0.34. And on x, we have in minus, we have 0.94. That's the vector. I'll just click OK, save and exit. I'll go to my part tool table library and I'll try to find this tool over here. Let me update. Yeah, and we need to update the component. Why it didn't update it? Update the component. Interesting. Ah, Okay, I need to reload it. So here is the linear now. Let's see it now. Okay, nothing's changed. Okay, everything still remains the same. But now what is different is that we have now in the cutting point, we have this component axis and we call it linear. Now you can go over here and you can actually change it to anything you want. How cool that is. And of course, if you break the limit, it will show you here the limit. So the limit works accordingly. Very beautiful. Of course, there is a feature like somebody is asking me, okay, how we can detect now the diameter. Of course, you need to know what is the diameter, where you screw it. You know, you will measure it, and then you will put the values here. If you just want to play with, you can just roughly come over here and say, okay, this is 90.5 maybe, and that's basically it. And this is the revolved one. What I like is the detail over here in this area over here, because it's good for the collision checking especially. So extending this component more. So let me imagine that we extended more than usual. It really has importance of collision check detection in this case. Let me just roughly check it out, the questions. Okay, the question is like, can we able to convert tools from older tab file one at a time, or we can entire the library? Actually, that's a good question. I'll have to check it and then I'll inform you in the next webinar. Okay. About downloading the specific post processor, as I shown over here, I will be giving the link in the by email, but basically you need to have an access to the reseller page of the Salesforce in order to download it. Okay, let's continue. I hope you enjoyed so far. The next holder that I want to show you is the angular head. Let me show you this one. So this is with the adapter itself, with a also holder. It's here. Here we have one attachment, which will be the Z-axis, and then we have also another one where it is. Yes, this one, which also have the coordinate system here, and it has also another coordinate system there. I didn't break this angular head to the Collet and stuff. I think it's not so important for the webinar. So I'm just going to show you how you can do it. As you can already see, I already prepared the coordinate system, so we don't need to waste so much time with it. So I think it's not so important. I will just mention, the delta that is necessary to understand how to use actually this holder. So I'll be just clicking on save as, and I will of course put it into webinar. I will call it Angular holder. Again, the STL, I will go to the options, choose the coordinate system, do not output to the positive space. Of course, it's okay. And I'll just save it. Great. Then I will be going to another component. I will do exactly the same. This time I will just hide one body here, which is this one. So I will first export this. It doesn't have the name. I will be calling this like a Z-axis, which is really like it can rotate along the around the Z-axis. So I will just do a save as. The coordinate system, it's coordinate system 1. So let's go to the metric. And STL, I'll go just C. coordinate system 1. Okay. Save. Yes. Just selected body. Then I will hide this one and unhide this one. And also, as I said, I will be exporting it together with what I call it itself. So I will just export it, but by the coordinate system 2. Metric. I'll call this one as a B axis because it's around, or I can call it A axis, but it's really up to you how you're going to call the axis. It depends really of what it is there. Yes. So, so the options, coordinate system 2. I'll click OK and save. Great. Back here, back to the tool components. I will just edit tool components library, the same TLV, and let's import some holders. So I'll just add a holder. Let me go to webinar Angular holder. I'll put this HSK 863. Let me rename it. And the joints here, it's pretty easy to define. It's in this case, it will be the C-axis, okay? But this time, the axis will not be a static one, but it will be actually a rotary axis. So let me just delete this one. So I'll call it C-axis itself. Let me go to the show hide picture. Great. Doesn't look anything so special. The only thing what we need to know is to shift this over here. It is right exactly in the middle. So how to do that properly? Again, you can use the measurement. You just, click over here, hold the control key, click on any entities here. We have here like 98. So I'll be just, putting here minus 98. And here it is. It's the C-axis and X-axis data. This is what you will actually see there. So I'll call it C. Rotation, it's around Z-axis itself. Rotation point, I'll just leave it as it is. It's perfect. The only thing I will just change, you can also put the limitation. This C-axis doesn't have any limitation, but if there is, you can actually really put it, for example, from 0 to 270 or so. You can actually do it. So in this case, I'll just leave it as it is. I'll click OK. Great. The next holder. Let's go here, 3D model. Webinar Angular holder, but a C-axis component is over here. We forgot to measure where it was, but even though that, I can go back to the SolidWorks and really, measure it where this actually model was, but remember this is STL, so the base of the STLs, it's pretty nice because wherever the round starts, it will start with the splitting the facets. So the center, it's right there of the C-axis. So we can actually, we don't need to go back to the to SolidWorks to do that. So the connections, I'll be calling this A-axis. Again, at the rotary axis, this one to remove. Calling the okay, you can also do a F2 if you want to rename it, just for your information. My coordinate system will be exactly from this surface up to this point maybe. And that distance is 61. So I was also holding the control key in the case you didn't see it. So I will just call 61. That's it. And this time, the rotation point is really on 61, not 64, 61. Let's go to the axis data. Pay attention that the rotation here is along the y-axis. So here is the y-axis, I'll just call it A. Along y-axis, rotation point, it's from this one, not from the coordinate system, okay? So just put here minus 61. And min limit, max limit, let's put like here something. Yes, so just we have something to rely on. I'll click OK. I will be calling this C axis, even though here I call it A. A it's the joint, and C is the component. Okay, let me go again, add the holder. A axis here, you can, first I will just import, let me go to the webinar. Great. So the connection here, it's pretty much perfect. I don't need to change anything, and just I need to say where it is here. So I'll just click on this one and going up to this. We have 92.5 to the joint, 92.5. Perfect. Here it is. I think that's all set up. I'll just rename this. I'll call it A-axis. Let's see how it is to import it into a part tool table library. So I will be just doing a drag and drop. So the webinar, we have the Angular holder, the tool item will be defined. Let me just show it over here. Looks great. The only thing that actually I forgot that I put everything to be, I didn't put it, I just say that it's all direct, so it will definitely rotate everything. So I missed that one. So then we have the C axis, then we have the A axis. Voila. Very good. For the end, I'll just put any Endmill. Here we go. So nice. It's outside holder is 35, and you can affect really 35 or any value that you put here, 27. So you can really go and use the measurement. Click here, click there. It's really 27. Perfect. But furthermore, we have the the cutting point. As you can see now, everything is rotating because all our holders are directly driven. So I will fix that later. So let me just change it immediately. So I'll just save an exit. Let's go back to the tool components library again, showing you the great association. Library. And then the Angular holder here is not direct, but it's like either, yeah, it's a gear. I'll just leave, maybe like something like this. The C axis is, I can say it's not driven and not driven. Or I will call it also gear. Let's see what will happen. Save and exit. Let me go to the part tool table library. It's a gear. Let's try also here. Yep, it looks great now. Okay, so, but now what is the point here? We can actually create now angular position up to our wish. So we can change the C axis here. We can change the A axis. So it's so nice to see everything is rotating correctly. And that's it. Now, okay, I see a question. Okay, how we can define any other cutting position, yes? So the question is coming, should I define a new cutting point? Okay, the question, the answer is no. You cannot just add a cutting point here, because adding the cutting point, it will basically copy the same axis status from this joint. So for particular tool item, remember, these axes are not kinematic axis. This axis is indexable axis. You don't have the simultaneous option on any of these. It's just like basically unscrew, screw stuff, okay? So in that case, this is not correct way to add another angles. But what you should do instead, if you're interested, to have the same tool, but with different angles, what you should do is you should just copy and paste, and now you can actually, with this, for this cutting point, for the same tool, basically just different tool offset. As you can see, this tool offset number, it's 8, but this one is number 9. I can actually change to any other now component axis. Great. Any more questions? Let me see it. There is a question, can you explain drive unit type? It is covered in the first webinar. So actually, basically, I explained there in depth. Also, there is a presentation about it. Okay, it seems that it's not. Okay, let me repeat it again. So let me go to the tool components library, and I will just take the webinar here, and I'll call it Angular holder here. Okay, so so whenever you have a joint, you need to actually say what this kind of how this joint actually do. Now, how it is actually connected to the main drive unit of the station on the spindle. So it can be connected in any many different ways, and it is direct, not driven, self-drive, or a gear. When it's a direct, it means that whole holder over here will spin if it's directly connected to the top station of the spindle. Then we have not driven. It means it cannot rotate. Okay, so you cannot use it at all. For example, this is an example of the old turning holders, for instance. Then we have a cell drive. This is the attachments on the spindles that have their own spins, you know, and spindle drive engines on their holders, and each component it rotate afterwards. Okay. And then we have a gear. The gear we'll be using, you know, for everything that has a gear, like in this case, it can be also this one, in the case when I don't want to rotate everything, but it really has the gear with a specific ratio. It means that this element will not be rotated either. Also, if it's and also it will affect to all other then. Okay, so the link, it's connected. So only the top one have the influence to the next one, and then next one it can be not driven, and it will have influence to all other. I hope that's. Let me check also the presentation itself. I think I have mentioned. Maybe not. Maybe yes. Or sorry about that if I didn't. Yeah, interesting. I didn't. Okay, so it was a good tip then for you. All right. Any other question? Let me see. Oh, yeah. Okay. So there is something that I forgot to show. Also, for all of you who have, for example, a lot of holders downloaded from the website, okay, you can also use pretty primitive. Still, it is in the stage of development, but anyway, I want to show you guys because it will work for 80% of your cases. Is the feature that we have over here. But before I go there, I would like to show you that in specific one multi-master tool that we used in the previous webinar. It was this one. And basically, what if I tell you that you can import all of these, avoiding all those steps that I showed you so far with a single click? So what is the way to do it? So you just open it, okay? You go back to your SolidCAM, go back to your toolkit over here. You can have completely all closed, and here you have an option to import tool assembly from the CAD. Now, pay attention, then this is not available if you're not in SolidWorks. Okay, so you need to be inside the SolidWorks in order to do it. So into standalone application, this option is completely unavailable. So clicking on this, you will be warned, okay, use this particular feature, but the 3D model should be in active window. Do you want to continue? And I'll click cancel because here I have my CAM part, okay? So if you have pretty complex CAM part, that will take a while, you know, and you will stuck probably your toolkit for a moment. But what you have to do, now you're able to switch to that particular holder. And now you can actually do import tool assemblies from CAD. So I'll just click on that. Do you want to continue? You'll click OK. And here's the interface. So basically you have the folder where you would like to store your holders, and you can generate it as a milling tool or as a turning tool. Okay, I'll just to remind you, it is still in progress of development, but for these kind of applications that I've shown you, it will work completely fine. But for instance, if you have like an angular holder or stuff, okay, please don't expect that we will do everything automatically for you, okay? So in this case, it's better to know actually the real background, how everything is created, and using it on pretty much standard holders and tools, you're free, you know, to use this particular wizard. So I'll just click on generate as milling tool. And what will happen if he will analyze all solid models inside the project, and it will take, you know, the origin itself, and it will divide into segments. And here you go. As you can see, he detects some of them. Probably, as you can see, the colors itself shows, okay, this is a cutter, this is a shank, this is a holder. This is completely wrong. Also, this looks like completely wrong. So what you can do now, this one, as I can see, I don't know what it is. I believe this Endmill is actually this holder. So what you can do a right click and you can make a focus. So you can clicking on any of the components, he will actually highlight each of the component. So this one, it's actually a holder. So I can do a right click and change to holder. So every of the element you can change to specific type, because there is no engine that will tell you now the top one, it's always the holder or the shank or something. So for this, you need to do it actually by yourself. So this is a holder. This element is actually shank. Then this one is also shank. This is okay, but this is actually a milling cutter, and I'll just call it an end mill here. That's it. Not too bad. I will just put it on the top level here, if I can do that. Here you go. And I'll just click OK. Now it will bring you back to the toolkit. And here you have this element open over here. So you can just basically, you know, drop it here, mount it to station. You can open the machine view, zoom it. Here you go. All right, so, and also what I'm going to do, where's the angular holder? Let me just try to attach it again. This is how it looks like, guys. That's it. I hope you guys enjoyed this webinar. I'm very glad I see so many questions. So again, I will keep the practice for the next webinar. I'll answer to the most of the questions. And the next webinar series will be about importing any turning tool components. So please stay tuned on this one. And if you have any questions, please visit our forum. Okay, you can also write us the questions there. If you have any suggestion which particular tool holder or something you would like to see in that webinar, please write us there, or you can also contact direct support, and we'll try to use a particular example that you shared. Thanks again, and have a nice weekend. Bye-bye.